All right, so the past couple days we've been working a lot with this sine curve. And remember, the equation for the sine graph was y equals a sine of b theta plus c, where a was the amplitude, b was the number of cycles between 0 and 2 pi. We used b to find the period, so the period was 2 pi divided by b. And then c was our phase shift. That was for the sine wave. Today, we're going to be talking about the cosine wave. So the cosine, the equation is basically the exact same except for it's cosine instead. So it's y equals a cosine of b theta plus c, where a is still the amplitude, b is still the number of cycles between 0 and 2 pi. We still find our period in the same way, and c is still our phase shift. So none of this a, b, c, or the period, it doesn't change. We still are finding it the same way. The graph is just going to look a little bit different. So if you have your unit circle, pull it out right now so you can follow along with what I'm doing. So here, we're going to fill out this same chart that we did in class, but in class we did it with the sine of theta. So this time we're going to be doing it with the cosine of theta. Remember, cosine is the x values. Last time we looked at the y values. This time we're going to be looking at the x values at these degree measures. Okay. So at 0 degrees, the x value is 1. So at 0 degrees, this will be 1. At 30 degrees, it's the square root of 3 over 2, which if you put that into your calculator, you will get 0.87. At 60 degrees, it's 1/2, so it'd be 0.5. Remember, we want these as decimals because it makes it easier to graph them. And then at 90 degrees, the x value is 0. At 120, it's negative 1/2, so that's negative 0.5. At 150, it's negative square root of 3 over 2, so that's negative 0.87. 180, it is negative 1. At 210, it's negative square root of 3 over 2 again, so that's negative 0.87. 240, it's negative 1/2 again, so that's negative 0.5. 270, it is 0. 300, it is 1/2, which will be 0.5. And 330 is the square root of 3 over 2, which is 0.87. And we get back to 360, and that is back to 1. Okay, so now let's use these points, what we just found, so those x coordinates, to graph our cosine function. So just like it was on the sine, our x-axis is the degrees, the degree measures, and the y-axis will be cosine of theta. Last time it was the sine of theta, but we're not working with sine, we're working with cosine, so the y-axis will be cosine of theta. So at 0 degrees, the cosine is 1, so it's going to be that point right there. At 30 degrees, the cosine is 0.87, so it'll be that point right there. 60 degrees, it's 0.5. 90, it's 0. 120, it's negative 0.5, so I'm going to go down 0.5. 150, it's negative 0.87, which is about right there. 180, it's negative 1. 210, it's negative 0.87 again. 240, it's negative 0.5. 270 is 0. 300 is 0.5. 330 is 0.87. Whoops, come on. And then 360 is 1. So we have all those dots. Now we're just going to connect them to create our cosine curve. So this is going to go down, and it's just going to come back up. So unlike the sine curve where the first, the last, and the middle were in the same spot, this time the first point and the last point are in the same spot. And then the bottom point is completely on the opposite end. So the first and the last are in the same spot, and the bottom is the very lowest point. So instead of first, last, and middle being the same, on cosine, only the first and the last are the same, and the middle is the opposite. So let's just look at this side by side comparison of sine and cosine. So if we look here, sine starts at 0 and it ends at 0. Over here, cosine starts at 1 and it ends at 1. Okay, so if you remember, what the amplitude on sine was 1. Over here, my high value is 1, my low value is -1. So 1 and -1 are 2 apart, so the amplitude on cosine is also 1. So on cosine, you start at your amplitude and you end at your amplitude. Versus where on sine, you always just started at 0 unless you had a phase shift where you would move up or down. Okay, so on cosine, you start at 1, you end at 1. So you start at your high point, you end at your high point. Whereas versus sine, you started at your middle point and you ended at your middle point. There are a lot of other things, so pause this video and see if you can make any other observations about the differences between sine and cosine. Okay, now let's get into the fun stuff, actually graphing these. So still, we're going to label our A, B, and our C, and we're going to find our period. So I'm going to start with my A. My A is the value that's right in front of cosine, so my A is 4. All right, so the formula is y equals A cosine of theta plus C. What just happened? I don't know what happened. I'll write it again. Y equals A cosine of theta plus C. Okay, so our A value, again, because my iPad hates me, so my A value is 4. Okay, my B value, oh, I should have put a B right there. The struggle is real, guys. Okay, my B value is 1/3. So to find my period, the period is always 2 pi divided by B. So my period is going to be 2 pi divided by 1/3, which is 2 pi times 3/1, which equals 6 pi. Okay, so this is my period. And then my C value is +2. So C equals +2, which means I'm going to go up 2. So I'm always going to look at my C value first. So my C tells me that I'm going to go up 2. But remember, we always start at our high point on the cosine graph. So I'm going to go up 2, but then I'm going to go up whatever my amplitude was from there. So from there, I'm going to go up 4. So I'm going to go 1, 2, 3, 4. That is going to be my starting point. Okay. And then my starting point and ending point are the same. Write that down. Starting point and ending point are the same. My ending point here is 6 pi. So my ending point is the same. It's going to be right up here at 6 pi also. Or at 6 also. Okay. And then the middle point is my low point. So I'm going to go halfway between 0 and 6 pi. Halfway between 0 and 6 pi is 3 pi. Okay. And then I'm going to move down whatever my amplitude was times 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And that will be my low point right there. Okay. So on the cosine graph, I really just want you to find these 3 points. Once you find those 3 points, you can graph this because it just goes down and it comes back up. And that's our graph right there. Okay. Let's look at one more example. So let's do this example. So again, we're just going to identify our A. So our A value here is 2. So my amplitude is 2. My B value is also 2. Remember, B is the number of cycles between 0 and 2 pi. So it is not my period. I have to use B to find my period. So my period equals 2 pi divided by B, which is 2. 2 pi divided by 2 is pi. So my period is pi. Then my C value is -2, which means I go down 2. Okay, so I always start at my C value. So I'm going to start and I'm going to go down 2. And then from there, I'm going to go up whatever my amplitude is, because you have to go up to your high point. So my amplitude is 2, so I'm going to go up 2. This is going to be the starting point right there. okay? And then remember the starting point and the ending point are the same. So my starting point is 0. My ending point is going to be pi. So it's going to be right here at pi. And then I'm going to go halfway between there, which would be pi over 2. And I'm going to go down double whatever my amplitude was. So my amplitude here is 2. So I'm going to go down 4. So I'm going to go 1, 2, 3, 4. It's going to be down here at -4. So I have those 3 points now. I can just connect those dots. And make sure you have it curvy like this because this is a cycle. It's going to continue. This graph continues to go along here forever, and it's going to go forever in this direction also. Remember, but we're only really drawing one cycle, but we have to remember that this continues to oscillate forever in the negative direction and forever in the positive direction also. Okay, so come to class tomorrow with any questions that you might have. We'll do a couple more examples, and make sure you take the quiz, make sure you took really good notes, go back and watch this video again if you're still confused, and I'll see you guys tomorrow.